Okay, I am going to get started. Welcome everyone to uh, the demo of the the new Vitess orchestrator. I am going to jump very quickly into this because I'm assuming all of you are familiar with Vitess, so I'm not going to be doing much of intro. In fact, this is going to be the last slide you're going to see. So what I'm going to show today, I will bring up a full cluster and I'll walk you through what orchestrator does when things fail or change. Um, the reason why I have this picture here is to show you the components I'm going to bring up in my demo cluster, and then we will talk about how we fail things and what orchestrator does. So in here, I will bring up a VT gate, which is for the app, but for the sake of in the demo, VT gate will do nothing. We could probably do the entire demo without VT gate, but I'll just bring it up in case somebody says, oh, let's try running a statement or something. I will bring up VT tablets, and I will bring up HCD as topo server, and I will also have VTCTLD app. So we will have 1, 2, 3, 4 components running. So while I'm running the demo, you are absolutely welcome to interrupt me and ask questions, because it's likely that if you don't ask any questions, I may finish the demo in 5 minutes. Hopefully not, but we'll see. Okay, so and the other thing I wanted to talk to you about is there is actually an older integration of the orchestrators. I assume many of you already know. If you search for orchestrator here, you can find it. This is essentially at this point, or will soon become obsolete. So this is where you run stock orchestrator, just the way it is from Shlomi's repository. But you make some changes to Vitess and you make some changes to orchestrator. And so the stock orchestrator has external integration hooks. You basically wire Vitess up with those hooks, and then things kind of work. But this has been a rough experience for many of you, because there are places where things don't there are gaps sometimes, and there are overlaps, and gaps have caused problems, and overlaps have caused even bigger problems, because when orchestrator and Vitess start fighting with each other, things end up in a very unhappy state. So this new integration solves all those problems. So in other words, in the new demo, none of these instructions are required or even valid. So that's the this thing. And we'll go to this RFC later. So I have now going to bring up a cluster. So in this modified cluster, I'm going to talk about what I have changed. So this is so I'm going to use the local example, a modified version of the local example. I'm only going to bring up the commerce key space because I can demo all the features with just one key space. As you can see here, I have commented out init shard master. This is by far one of the coolest things we have done. I don't know if how many of you have come to Vitess and got stuck at this step. This is by far the biggest barrier to entry for Vitess. So init shard master is not required, and we'll talk about how we fill that gap with orchestrator. Apply schema should work, but because of how I sequence my demo in this script, it will fail. So I've commented those out. So I still bring up VT gate, and I bring up HCD and VTCTLD, as you can see here. To the VT tablet, let's see. this is a custom VT tablet script. The way it differs from the local example VT tablet is there are two flags, two changes. One is I have disabled active reparents, which means that VT tablet does not touch the replication at all. If in the external integration, you are required to turn this on because Orchestrator would not fix your replication if it was broken, or it wouldn't like initialize your the VT tablet, that the MySQL, a new pod that comes up by pointing it at the master. The other thing I have is the other flag which I have removed is enable semi-sync, which is usually here by default. Cool. Any questions so far about the scripts? No questions. All right. So I am going to bring up, I should have done this right in the beginning. I will bring it up now. Org test. In this, what I am bringing up is a full cluster. Let me, so I'm actually, the other modification, I'll show you what our test does. It was here, right? Yes. So the other change I made with, in the case of, with respect to the original commerce example is I've added another cell, which is zone 2. And I'm bringing up a couple of more VT tablets under here, 110 and 111. So this cluster will have 5 VT tablets. Let's look at VTCTLD. All right, so VTCTLD says there is one cluster. So as you can see, my cluster is up, but one thing you'll notice is there is no master, right? So if you click on this stat eye, all these VT tablets are unhappy. This says there's no replication status. I don't have the database. There's nothing I can serve in terms of query. So now I'm going to bring up the orchestrator. And let's do that. So here is the orchestrator command line. I'm going to spend a couple of minutes explaining how it's different from the old one. And let me show you the VT-gate command line. So this is how the VT-gate is running. You can see here that the VT-gate has some topo parameters. This set of parameters are required for every Vitess component. This is basically what wires everything up together, because you're telling this is basically the starting point for your discovery, right? The global topo. You see that I have HCD2 and the address and the root. So I won't spend time on this because you can read up on the documentation about what these mean. So VT-gate has this. If you look at VT tablet, it will have this. And what I am now doing is orchestrator accepts these parameters also. This is in the stock orchestrator, these won't exist. What this means is that this orchestrator is a native Vitess component, which means that it can do anything and everything that a Vitess component does. There is a config file, and I'm saying run it as HTTP. So let's look at the config file. So here is the config file. I have debug to true, which this is generally not recommended if you're running in production. It's very spammy. I have durability to none. We'll come back to this. And there are these 4 things which you should typically not set. I guess you do have to set these in production. Orchestrator needs to know the client, user, and password, but there are ways to specify that through a separate file, which can then be specified as a secret. The 2 additional parameters I've added, which do not exist in the orchestrator, is the replication user and password. So in other words, if you were using this as orchestrator, this should be your secret file because it has passwords in it. And you can see that I'm using SQLite. Orchestrator can run other backends like MySQL, for example. In this case, there is no shared state. Uh, uh, all the state of the orchestrator is ephemeral. If you restart the orchestrator, you can wipe this database and start from scratch. There are some non-ephemeral things like downtime and maintenance windows and things like that. Those we will change to use the Vitess topo eventually. And these three are essentially generally safe properties to set in the orchestrator. The recovery period obviously should not be 1 second because that would cause immense amount of flapping under certain conditions. Actually, let me change this to 5. 5 is slightly better even for a demo. So the idea is that if orchestrator performed a dead master recovery, you won't be able to make any changes to that cluster for the next 5 seconds. That's what this means. Any questions so far? No questions. Okay, I keep going. All right, so I'm going to bring up the orchestrator and quickly go to the browser and look at the orchestrator. As you can see, orchestrator has come up, but it says there are no clusters. But orchestrator has a 15-second cooldown, as you can see. So after the cooldown, it says, oh, lots of things are happening. And if you go back here and refresh, it says, I have discovered the cluster and I see that there is commerce 0. If you click on this, the first thing you will notice is that there is actually a master. I should say leader. And now if I refresh on VTCTLD, there is now a master. So if you look at click on the status, it is all healthy. If you click on the replicas, they're all healthy. Now this cluster is now healthy and can accept read and write traffic. So the init shard master step that used to be done as a very as a step that as a special step in Vitess when you brought up a cluster is not required anymore. Orchestrator takes over that part. As a matter of fact, the recent changes that we made in Vitess, you are not even required to really do init shard master anymore. An init shard master and emergency reparent shard are identical. So you could do an emergency reparent shard that can initialize your cluster at this point. So which is essentially what orchestrator did. Cool. So now we have a running master. Let's now, I'm going to bring up my notes to see. I've shown you old instruction. Oh, I need to show you the branches. So the orchestrator version that I'm running can be found in you can see that there is a OC3 branches. So in the OC3 branches, I'm currently running the OC4 version, so OC2 is about to be merged onto the main branch. The next one is the durability PR, which I'll create, and finally the lock shard PR. So I'll talk about these later if we have time, what these branches do. Cool. Let's see what else I need to talk about. I've showed you the scripts and config. Let's do reparenting. So I'm now going to go to the orchestrator. But before I go here, let's look at this thing. This master is writable. You can see that these are replicas. You can see that this is must not promote. So this is our RD only. So here you can see not this one. Where is my local host? So I have 102, which is RD only, and the rest are all replica. And you can see that the replicas are all promotable, and RD only is a must not. This one is a must not promote because it's an RD only. So if I try to do this, it's going to get angry at me saying you're not supposed to do this. No? So That's the first one. Now I'm going to do this. I say promote as master, click, and you go to VTCTLD, and 100 has become master. So this is something the external orchestrator can do, but this version of orchestrator does it differently. The action it performs is essentially the same thing that plant reparent shard does. So there is no difference. You could actually, you basically with this, you don't need to ever do a VTCTL client plant reparent shard. You can just drag and drop, and that will achieve the exact same functionality. So that's the cool part. And what that means is that errors served will be less, because it'll first shut down VT tablet and wait for existing transactions to complete, and then only it will perform the failover. So far, so good. All right.
Sugu, there's one question. If you could increase the size of your font for some, and then I think just for everybody else on the call, please feel free to just unmute yourself if you have a question for Sugu. There are some questions in the Q&A panel.
Oh, let me see. Q&A. Will you be covering what integrations are added to Orchestrator for the creating of master in a Vitess cluster? Well, I just covered it. There is no resolved thing. Why not enable semi-sync? Of course, we'll get to that. Please increase font size. All right, I'll increase all my font sizes. So this font size is increased. I assume this is readable, but I'll increase this font size also. Okay, and I will increase this font size. All right, all good. Please feel free to speak, by the way. I mean, I feel like it feels weird that no one is talking, but I'll keep going. What is this? There's only chats. Okay. What if I want to specify a zone 1 replica to be a master? Seems like orc will choose one randomly. So what I did there is I specifically said, in this case, I promoted a zone 1 replica, right? So you can explicitly promote any replica. So this is a zone 1 replica. This is zone 2, right? So I can say promote this. So you can explicitly promote anything you like. But you can, Orchestrator has thumb rules about preferring replicas in the same zone to be the master. So we can talk about that at the end, about how it does that. Oh, what happened to, whew, it took a while to reappear. All right, so does that answer your question? Will the operator work? Will the operator work with Orchestrator out of the box, or changes are required? I don't know the answer to this question yet, but that is actually next on my task list, to actually put the Orchestrator with the existing operator and see what it does. And if it doesn't do the right thing, I'll basically fix. But eventually, my goal is to actually add Orchestrator as a component of the operator, right? So in the operator, just like you specify how to bring up VTCTLD, you should be able to specify how to bring up the Orchestrator. Zoom/webinar mode, we cannot unmute ourselves. Oh, Sean, can you take a look at that? It says people cannot unmute themselves.
Yep.
Does Orchestrator help to bridge the gap between tablet reparents and MySQL instance failovers? That is, when you have n virtual shards per MySQL D, today we do PRS for one tablet and then TER for the others. That's an excellent question, Matt. That is a feature that is coming soon. Yes, I have that in my, I believe I have that in my, it's covered in the to-do list. But yes, so we'll get to that. Yes, and the answer is absolutely operator has to do this. And operator has the ability, sorry, not operator, orchestrator has to do this. And orchestrator has the ability to mine this information out from the Vitess topo and do the right thing. So I think essentially, if in your cluster where you have multiple multi-schema, where you're running VT tablet in multi-schema mode, orchestrator should be able to know that, oh, the following VT tablets are pointed at the same MySQL instance, and therefore I should actually update all of them to master. Cool. Can somebody who can unmute, try unmuting themselves and say hi? Looks like it's still not possible. Okay. Maybe when we get out of presentation mode. Is there a Q&A mode? Maybe if we enter Q&A mode, it'll automatically happen. All right, I will keep talking. I will ask my own questions then, and I'll keep checking on the Q&A panel after every feature that I show. So the next thing I'm going to do is, we talking about model difference between VT tablet, between the Vitess version of Orchestrator and the stock version of the Orchestrator. The biggest difference between those two is the way Orchestrator discovers instances. The way Orchestrator, the stock Orchestrator discovers instances is by looking at which replica is connected to the master. Like if you give it the master, it'll find out all the replicas that are connected to it and discover the instance that way. Or if there is a replica, it'll go to that master and then eventually find the rest of the replicas that are connected to it. So that's how it discovers a cluster. But if you bring up a brand new replica and don't point it at the master, there is no way for Orchestrator to know about the existence of that replica. You could force that information into the orchestrator saying that, by the way, there is this instance, please discover it. But as far as the orchestrator's discovery mechanism is concerned, that remains a separate cluster because there is no metadata that says that that replica belongs to this cluster, because the only metadata that it uses is based on how replicas are wired up against the master. In Vitess, that is different. In Vitess, because of the fact that we bring up a VT tablet against a shard, a key space shard, here the orchestrator can know, even a completely orphaned replica, that it is part of the same cluster. Let me see if there's any questions about this. Oh, there's lots of questions.
Good news, we can now unmute,
Woo!
FYI.
There is an anonymous attending asking, can I change replication source from master to another replica in Orchestrator? The answer is no. That is the reason why it is no is because it is not allowed by Vitess topology. Vitess topology requires all replicas to be connected to their master. It is we could look at supporting hierarchical replication. It's just that we don't know if it will break in any way. If we think that it won't break in any way, we can actually start allowing it. But if you look at the traditional planetary parent shard, right? If you issue a planetary parent shard, it'll choose a master and bring all the replicas under that master directly connected to that master. So no hierarchical replication. Hopefully that answered your question. Hopefully that is the question, and hopefully I answered it. Okay. So now what I'm going to do is actually, I'm going to stop global recovery and go here and bring up a new VT tablet. Find out which number, 100, 102, 101. Let me bring 112. Is it 112? Yeah. Oh, no. Okay. It's going to bring up 112 under zone 1. So it's still, this script by default brings it up under zone 1. So let's see what happened here. Let me refresh. It's brought up 112 as RD only under zone 1. If you look at the status, it says it is serving, which is strange because it should not be serving. The reason is because, we'll look at this later. If you refresh here, oh, it feels like this did not really disable global recoveries. This is a bug in my, in my code. It shouldn't. So what it did was it discovered that there is this VT tablet that just came up that is just hanging in the middle of nowhere and decided to wire it up to the master. I wanted to first show that it was, it wasn't doing, and then now show, like when I enabled it, I wanted to show you that orchestrator wired it up, but well, it did it without asking my permission. All right. End result is, if you bring up a new VT tablet, orchestrator will take care of wiring them up for you. Now the big one, which is, let's bring down the old master. So we are going to kill the MySQL instance of 101. My down 101. And if you now look at the orchestrator, it's saying, looks like something is not happy. So orchestrator is now quickly asking replicas, are you okay? Are you receiving anything from the master? And then it finally panics and starts to perform some actions. So now if I do a refresh, it has reparented to 1700. And if you go back here, 100. So it is now reparented. And 101 is essentially at this point dead. And you'll probably see orchestrator complaining about it, saying that 101 is dead, 101 is dead, 101 is dead. So let's undead it. Up 101. So as you can see here, 101 is missing. It should be missing, yeah, because it would actually show up in the, but now too late, because as soon as 101 came up, orchestrator probably rewired it. So as soon as MySQL comes up, it says, oh, this one is orphaned, even though it was a previous master. It says this is hanging around, not pointing at anyone. I'm going to wire it up to the existing master. So in the older integration, this was done by Vitess, and sometimes orchestrator and Vitess were not getting along. And this is the most common problem where you end up with co-master scenarios. So I will actually create a co-master scenario and show you what happens. I brought up the old master and the auto join. Let me see if there are any questions. There is one question. And when we will have orchestrator on Vitess operator? Very soon, maybe end of this week, who knows? Depends on how much time I get to work on it, but it is next on my task. Cool. Oh, actually, it may not happen by end of the week because there are 2 PRs. Those 2 PRs have to be merged and people have to review. So I don't know how fast that will happen, but you can definitely build off of those branches and start playing with the orchestrator if you are really, really impatient. So cool.
I have a quick question.
Yep.
Is it actually desirable to have the old master rejoin the cluster? Because I think in some of the Vitess docs that I've read, it says that if a master dies, you should just kill it and reclone a fresh instance rather than having it rejoin. So what do you recommend, and are both an option with this orchestrator?
Right now, I would still recommend throwing it away. That's if you can afford it, right? If this is why we recommend small shard sizes. If your shard size is only like 200-300 gigs, it's just better to throw it away and build a new one. much safer to do it. But if you have like a terabyte size database, it becomes a different problem, right? It's not, it's a lot of work to restore, to throw away what you have and to restore it. So right now, what I believe what will happen, I haven't tested that part. If you brought a master back online that has previously failed, you could end up with an error GTID situation because there is a problem with how semi-sync is implemented. Is that if a transaction was started and the master failed to get an ACK from the replica and it crashed after that, then upon recovery, it actually completes that transaction, which it should not, but it does. So once it completes that transaction, and if in the meantime we had performed a dead master recovery, we would have wired up the cluster without that transaction that the old master has. And when it comes back, that will show up as an RNGT. That should show up as an RNGT ID. And I believe it should fail to connect to the master in that case. Shlomi, would you know what would happen in that case if you tried to say move this replica under that master?
So if the old master has extra transactions, this is a valid operation, and that will become an error GTID, and we can choose to block this in the case of recovery from that.
Got it. Yeah.
So the situation it will not allow is to replicate from a server that has purged GTID entries, which the new server doesn't see anymore. But we can decide that we do not allow to join if that implies error GTIDs following a recovery.
Cool, cool. So in that case, then I will add that protection where if a replica has an error GTID, orchestrator will not auto join it. Then you have the option of repairing it, or explicitly saying, okay, you can repair that master. Maybe you can reverse that transaction and remedy it. Basically, you call the shots about what should happen in that case. You could, but if there is no error GTID, it can automatically join. So we can have that happen. Okay. Any other questions?
Sorry, I have a question. I'm not sure if you have already covered it. Does orchestrator failover in case if a VT tablet process itself is down? MySQL is up, but the VT tablet process is down. Does this new?
Yeah, excellent question. Right now it doesn't, but it is in the plan. Perfect. I will show you what the work we have planned for the orchestrator later. And it's definitely planned to actually fail over if VT tablet becomes unreachable. As a matter of fact, there's a special request from the Slack people saying that you must make that happen. Because apparently, even though VT tablet never crashes, VT tablet is so awesome. Well, it can by the way, but we have not seen a VT tablet crashing, hard crashing without, for other reasons. But a network partition, for example, can prevent a VT tablet from receiving any traffic. If that happens, it makes sense to fail over, right? So, cool. Let's see what's the next step. Oh, so the next step is, this is where all the cool stuff happens. So let's say you are doing a failover and the failover fails in the middle, right? Then things are left in an inconsistent state. So I'm going to create some really, really bad states that have actually angered a lot of people in the past and see what orchestrator does here. So the first thing I'm going to do, so right now, if you did a reparent, right? The way the orchestrator works is, okay, I'm reparenting, let's say from 100 to 101. The new orchestrator steps, what it does is it designates this VT tablet as the master first. And after it designates the VT tablet as master, it wires up all the replicas to point at that MySQL. And once it points at that MySQL, it marks it read-write. And then it goes, and then eventually this VT tablet demotes itself to be a replica. So that is what happens if you do a reparent. But what if you started a reparent, this VT tablet gets designated as the master, and then things fail, right? And then operation goes incomplete. And so I'm going to emulate that situation. What I'm going to do is I'm going to change this VT tablet to be the master and leave everything as is. I'm going to do that with the tablet externally reparented command. Let's see which one to make the master. 101. Okay. Tablet externally reparented 101. So now if you go to VTCTLD, 101 is the master. You go to orchestrator. Oh no, I should have disabled it. Too late, too late. Oh, too late. Okay, sorry. So orchestrator, I wanted to disable global reparenting and show you. So what did orchestrator do here? What it did was it says, oh, things are not in good shape. 101 tablet was the master, but 100 is what the MySQL situation was. I'm going to fix this and bring this topology to a consistent state. So it says, I'm going to wire everything up under the new master. Any questions on this? Anybody wants me to repeat this with orchestrator disabled, or you understood what happened? I assume you understood what happened.
I was going to ask that you repeat it, but
Okay, I can repeat it. So this time let's stop the recoveries, and let's do 100. Okay. So now in VTCTLD, 100 is the master. In VTCTL, in orchestrator, 101 is still the master, right? So it remains in this state, and you'll probably see orchestrator complaining about this. It says, things are not happy, but analysis, like I'm not allowed to fix anything, please do something, right? So it's screaming about it. At this point, actually, if you try to write to this cluster, it'll all fail because all the traffic will go to 101, but 101 is read-only, and like that MySQL doesn't have any replicas pointing at that, right? 100. If you sent write traffic to VTGate, it'll fail because 100 is read-only. But there is nothing that's pointed at it. It's not acting like a master. In fact, the rest of the cluster thinks that 101 is the master. So now if I enable it, it'll say, okay, now if you see orchestrator will be doing, it is still in looping, and now it's saying, okay, I'm acting, and boom, 100 has become the master. Cool. Okay. So these are not the only things that orchestrator fixes. Essentially now this behavior of the orchestrator, the philosophy is, what is the desired state of this cluster? What is the desired state of each of these instances? If each of these instances does not satisfy the desired state, it basically pushes it towards that. Like for example, who is the master 100? So let's go mess up that master, right? Let's go to 100. Let's see, show. Oh, let me show you this really, really horrible situation. Show slave status. So this is a master, right? What I'm going to do is something horrible, which is, I don't know why MySQL doesn't do this. I should have. So I'm going to do bad stuff. Is this even good? Let me look at the cluster. This is probably a very bad idea. So 100. So I'm going to point this 100 at 110. Where's 110? So 110, right? So this replica is pointed at this master. So I'm going to point this master back at this replica. Yeah, I think
perhaps disable global recoveries?
Oh, yes, sir. Thanks, Shlomi. Global recoveries are disabled. I'm going to do this bad thing. Ta-da. All right. So orchestrator says we are in a co-master situation. These two replicas are pointed at each other, and this is not a happy state. This is actually, there are some people who run this. I have no idea why they do these kinds of things, but people do. This is like banned in Vitess, by the way. So if you want to do this, we don't allow you to the Vitess community. I'm just kidding. But if you do this, what and the reason why I want to show this is because this is a very common failure mode that happens if you integrate orchestrator, the external orchestrator with Vitess, because orchestrator will perform a failover and will issue a tablet externally reparented. And before that tablet externally reparented completes, Vitess comes in and says, oh, replication is broken, I'm going to fix it. And it fixes it, and then you end up in this situation. So in this situation, the state of the cluster is that most likely the current master is not receiving is read only. The real master is read write, but that is a replica, so no traffic is being sent to it. So now if you enable global recoveries, it should says, okay, there's a co-master situation, and I will do the right thing and make sure that the cluster is in good shape. It's checking on questions, no questions.
Hey, Sugu, quick question. I think you've basically answered it through the examples, but I just wanted to confirm. So it seems like, and this is all great, by the way. So it seems like Orchestrator, one of its primary tasks is ensuring that the MySQL topology always aligns with the source of truth, which is the Vitess topology service.
Exactly. Yes, the way the orchestra and that if that decision is made in a vacuum, things can still end up in a bad state, right? But the sequence of operations that orchestrator performs guarantees that the system will not diverge, right? Like you will not end up in a split brain. You'll not end up in a situation where someone who should not be a master accidentally receives and actually writes, accepts transactions that should not be accepted. Does that make sense?
Yeah, that's great, because I've seen that in testing in various cases as well. So that's awesome.
Yeah, you will not be able to do that here, I think, right? Based on this thing. Oh, by the way, I don't know how many of you have been following the blog series that I'm writing. In case you haven't figured it out, my secret plan is to implement that thing using orchestrator, and the specific sequences that I'm following are all rewrites to ensure that consensus rules are satisfied. In other words, which means that correctness and safety will be guaranteed by this cluster. There are still a few corner cases that we don't handle yet, so we'll fix them and tighten this up as time goes. Okay, so it looks like people can unmute themselves. Oh, there's still a question. The soon to be deprecated setup with vanilla orchestrator, will this work? It will continue to work as badly as it does now, essentially. There is no reason for us to deprecate that code yet. So you can continue to use the old integration of the orchestrator and live with those corner cases. But in my opinion, I would say, once we write tests and make sure that we cover all the cases that we want this orchestrator to cover, I think this orchestrator will be way far ahead of the old integration. There should be no reason why you should be using that anymore.
The one question I had was like, would it also handle non-Vitess clusters on the same orchestrator? If I have like non-Vitess and Vitess clusters? Can I host
Oh,
both?
no, absolutely not. Keep them
Okay.
separate.
Gotcha.
The Vitess orchestrator and Orca orchestrator will totally fight with each other and likely mess up your cluster.
Got it.
Do not try this at home. So I'm going to accelerate because, but we are coming to the cool. So what I'm going to do here is I'll show you only a couple of these things, right? So another thing I'm going to show. Let's go back and disable global recoveries. Is let's point to 101 at the wrong thing, right? So on a failover, when you wire things up, some replicas may get left out, right? So if the previous master was 102 and 101 was still pointing at that, and you reparented and something failed, 101 will be continuing to point at 102, right? So let's point 101 at 102. 100. And did I disable? Yes, I did. And change master to 17102. Oh. For some reason, MySQL does not like to remember. This is probably special code that they wrote. They don't want you to accidentally. Actually, I won't even start slave, right? Show slave status. Slave IO state is not running, right? Because I didn't restart slave. Let's look at it again. Oh, still not running. Orchestrator lazy. Oh, of course.
You disabled.
I disabled.
Recoveries.
Yeah. So before I enable, I want to show you the topology. So this is the topology. It says things are not happy. This and this replica is actually stopped, right? It's not replicating. So so if I could start replication, but what I'm going to do is I say just enable global recoveries, right? So this is what I call the autopilot mode. Wait a few seconds, and boom. It says, okay, this replica should be pointed at the master. It has also restarted replication. If I go back and do other bad things, like for example, 100 is the master. Let's go back to 100 and mess it up. Let's say set global, let's say show. So read only should be off for the master, right? So I'm going to set it on. Read only equal to on. Right, so this can happen when you're reparenting at the end. Things fail before you set to read only. If you see the orchestrator, it should, oh, it says you're on blackout period. So I need to go, I think the blackout period should go away soon. Yeah, I think it's gone. Now if you go back and see, it turned it back off, right? Because this, so there are a few other use cases, but I'm going to get to the pièce de résistance, which is this. So there are like all kinds of unwanted states that orchestrator will repair for you. Like a replica is read write, and it's pointing at the wrong master. So all those things it will fix for you. Now I am going to take us to the next level. Do I have time? I have 10 minutes, so I'm going to go fast. So durability is none, right? I can say I want durability to be semi-sync. Okay, so just to show you, see, these are all not doing semi-sync acts. Now I'm going to restart the orchestrator. And we'll have to wait for its 15 seconds cooldown. You have to figure out, now that orchestrator can instantly discover this from me, I think we should just get rid of these 15 seconds. Okay. Now, if I refresh.
Cool. You can also try to kill hub orchestrator for it to reload the configuration.
Oh, okay.
It might actually be a dynamic setting.
All right, you can see a few icons appear on these things. It says now semi-sync is enabled. Semi-sync is enabled for replica, but for RD only, it is disabled. This is what I call Vitess classic mode, right? Where replicas do semi-sync act. This is what enable semi-sync does. And if you do reparents, it will do all the right things. But I mean, this is not cool enough. Let's do something cooler, right? I am now going to change this to woohoo. Oops. Cross cell. So I'm going to restart this and wait those 15 seconds. So as you saw, there are two zones. I have 2 here and 3 on this side, right? So what I basically told Orchestrator is I want durability to be cross cell, which means that if a master successfully commits, that data must be present in a replica that is not in the current cell. So that is the requirement. So let's see if it has come up. Looks like it has come up. Let me refresh. And as you can see, the orange cells do not semi-sync ACK anymore. Only the blue cells semi-sync ACK. So let's do a reparent here. Wait. And come on, show me everything. Now the blue cell is the master. So this replica, even though it's a replica, it does not semi-sync ACK. It is only replicas from the other cells that do this ACK. Let's see if there are questions. There are no questions. I think you're all speechless by what I've shown you.
Sorry, I have a question.
Yeah.
We don't have to configure the VT tablet with the flag for semi-sync?
No. You can, as you saw in the beginning, I showed you the VT tablet. In this one, I removed the enable semi-sync flag. So semi-sync is not part of VT tablet anymore. Orchestrator manages it for you.
If we do configure, that causes any issues with
So the way I would do it is if you want to, I would recommend not managing semi-sync on your own with this orchestrator because it will split responsibilities in ways by which orchestrator cannot guarantee safety, right? But you can say, I want to enable semi-sync here, but I want orchestrator to only do failovers. But the problem is orchestrator does a failover. Who is going to go and repair semi-sync after that, right? So that is, and I'm almost sure you'll end up in situations where things are not safe or things can get stuck also, right? Because something accidentally semi-syncs and then data goes in the wrong place. Or so for total safety, I think semi-sync should be owned by orchestrator. So yes. Another question? So this is not even the best part. So ask me, or if someone is willing to tell, how many lines of code did I have to write to make cross-cell replication work?
How many lines of code did you have to write?
Yes. Let me show you the lines of code that I had to write. I had to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code to implement cross-cell. So I'm going to now give you the biggest reveal of the thing. This is the secret behind the new consensus blog post series that I am writing. In this new world, you don't specify cluster size, you don't specify quorum this, you don't specify majority, you don't specify all that. Instead, what you specify is who is eligible to be the master, how many acts should each master expect, and who are the replicas that have to acknowledge semi-sync. If you specifies just these properties to me. And as you can see, these are plugins. In other words, you can come up with your own rules, whatever rules they are, right? And say, these are my rules for durability, and register that as a plugin, just like you would register a Windex in Vitess. And then what we will do is we will guarantee all the consensus, all the things that a consensus protocol guarantees, which is safety and correctness, but then honor your durability rules based on whatever you want to configure. So that is a secret. And this thing is so powerful. The reason is because of how easy it is to specify custom rules, right? Like I showed you an implementation of cross-cell durability with just 5 lines of code. So that is how powerful this this setup is. And this is all thanks to Shlomi's awesome orchestrator architecture. And more importantly, the hardest parts of consensus are already implemented in Orchestrator, right? The ability to make sure that replicas don't diverge, that things don't, so that we don't accidentally accept writes that we should not be accepting, right? So those safety and in consensus protocols, there are we need to put anti-flapping rules. We need to make sure that you don't spam something that should not be spammed. So all those safeties are already built in Orchestrator because of the fact that it has been tuned over time with enormous systems that people have run, right? So taking all that into account, we just have to cover the last mile, right? And as you can see, we are covering these miles very quickly. So this is where things are going to end up. Let's see, any questions?
I have 2 questions. Are you planning on adding any other native durability rules besides these 2?
That is a good question. I haven't thought about it. So we should probably debate a set of, just like we did it for Windexes, we should debate a set of rules and then add them as natively available with Vitess.
And then the plan is actually that you can specify new ones via plugins and you won't need to fork Vitess to add new ones?
The answer is, in principle, yes, but in reality, probably not, mainly because there are no DLLs. There are no shared objects in Go. So which means that, yes, you don't have to fork, but you can add it, but you have to do your own build.
Mm-hmm.
So that is a limitation of Go. Some people have tried shared objects, but I don't think they've been very successful. Yeah. Oh, so let me show you what's on the roadmap. So here's the RFC. You can go look at it. It's a 6612. It's a Vitess issue. These are all the things that we plan to do in Vitess. There's more actually that will come that we'll discover as we go along. The one debate that we are going through right now is whether Orchestrator should be part of VTC-TLD or part of VT tablet or be its own. There are actually arguments in favor of all 3 possibilities. So that's a debate that we will go through also. So now that you've seen this, you now find it believable that we can build something better than what Raft does, right? There are actually configurations that people have come and asked me that are impossible to implement with Raft, with the Raft as it is today already. And those configurations, people are already running those in real production clusters. So it's kind of cool that we can now bring in safety with the backing of of a real consensus protocol. So basically make sure that all those corner cases are handled.
I had one question.
Yeah.
So it sounds like we're moving towards some level of customizable consensus does that mean that at some point we could do things like assigning priorities to different nodes, so that in effect you could have another cluster that you use just for disaster recovery purposes in another global region, let's say, and none of those nodes would be selected to become the new leader or master unless there were no nodes available in the primary or your kind of primary local region.
Yep. So I believe you're talking about this code snippet, right? So when you can specify the promotion rule. Orchestrator has the following, right? Must, prefer, neutral, or prefer not.
Okay.
And your plugin can dynamically change the promotion rules, right? Every time Orchestrator wants to do a promotion, it'll say, what's the promotion rule for the instance at this moment? And as long as this function works correctly, you can customize your preferences this way. So I have a feeling with these rules, you can say, when you do a promotion, always promote within cell. This may be enough, which will deprecate the existing orchestrator code that allows you to specify that as a flag.
Okay, that's great. So, sorry if you already covered that, and maybe I just missed it.
No, I did not. So, but yeah, so that's the power of these plugin, right? It gives you total control of the most important decisions that you have to make about failovers, and a very simple way to specify those rules. Come to the Vitess Slack channel. That's the best way to ask questions. The Vitess Slack channel, you can see it on vitess.io. The top right, there is a link to it. That's the best place to ask questions. All right. Thank you very much for coming, and I'll see you all on Slack.